Welcome, class. Let's take a look at sensory and motor tracts. So in this diagram, what we're looking at is a cross-section of the spinal cord. Now, there's no vertebrae here, because if there was a vertebrae, you can use the spinous process as a bony landmark for everything dorsal, and you could use the vertebral body as a landmark for everything anterior or ventral. So since we don't have that, we have to find another landmark that we could use. So the one that's the easiest is always that, right? The dorsal root ganglia. So once you know that's the dorsal root ganglia, everything coming in back here is dorsal. This is the dorsal horn. So if this is dorsal, everything here is ventral. That helps us in understanding, well, these are called posterior columns or dorsal columns, well, because they're on the back side. And the posterior columns are divided into these two pieces of pie. There's the fasciculus gracilis and the fasciculus cuneatus. And remember, the posterior columns are dealing with proprioceptive awareness and vibration. So knowing where you are in all your body parts in space and time and the vibratory sense is controlled by these two, the posterior columns, the fasciculus gracilis dealing with the lower half of the body, and then the fasciculus cuneatus with the upper half of the body. What else do we have here? We have spinothalamic tracts. Now, notice everything blue is sensory, and everything on the left side in red is going to be motor. Now, the author in this picture has separated them out so that on the right half, we're looking at sensory tracts, and on the left half, we're looking at motor tracts. But what I want you to understand is that whatever you're seeing here on the right side mirror images itself on the left as well. And everything on the left that's in red mirror images itself and will also overlap here on the right. Which means that you're going to have these two over here, and you're going to have this lateral corticospinal tract. You're going to have that over here. So they're mirror images. So we have spinothalamic, and you go, huh, that sounds like this, corticospinal. What are the differences here? Well, remember, if this is the brain and this is the spinal cord, sensory tracts go up and motor tracts go down. So anything that has the word spino in the first part of the word, spino something, is a sensory tract. And anything that has a part of the brain in the name, like we know that in the brain we have the cortex or cerebral cortex. So anything with cortico something is going to be a motor tract. All right, so let's look at the sensory side first, ascending tracts that go up. So we have a spinothalamic. Well, in the brain, there's a part of the brain called the thalamus. So going from the spine to the thalamus is the spinothalamic tract. That is a sensory tract. What about anterior spinocerebellar? Again, from the spine to the cerebellum, sensory tract. Then there's a posterior spinocerebellar. Again, another sensory tract. But if we go here on the left-hand side, corticospinal, it's starting in the cortex, ending in the spine. That's a motor tract. Rubrospinal, reticulospinal. The first word tells you where it's starting. The second word in it tells you where it's ending. So rubrospinal, corticospinal, reticulospinal, vestibulospinal, those are all descending pathways. Okay, so we have sensory and motor tracts. In terms of the sensory and the motor processing, the internal anatomy of the spinal cord is going to allow the sensory and motor information to be processed in a pretty organized way, right? You can see information can come in and then ascending tracts go up, and then you're going to have motor tracts or descending tracts go down. Okay, and you can see that sensory could be any type of receptors in the skin. Okay, they're going to go up, they're going to ascend, and then when they descend for motor tracts, they can go to muscles or they can go to organs and glands. So these tracts, we know that they are the highway for sensory and motor. We know that the sensory tracts go up, they ascend. We know the motor tracts go down, they descend. And as I explained before, the naming of the tract, it helps to indicate the position, where it lies. Is it anterior? Is it posterior? Is it lateral? And it'll tell us the direction of a signal. So if we're looking at the anterior spinal thalamic, it's telling us the position, it's anterior, and the direction going from the spine up to the thalamus. So those are impulses traveling up. That is a sensory tract, okay? Here again, on another view, but again, showing the same type of division. You can see the posterior columns here. You can see the spinocerebellar, posterior, anterior spinocerebellar, lateral spinal thalamic. Again, these are all ascending or sensory tracts. Okay, they're all going up. The motor tracts, the big ones are the pyramidal tracts, which are called the corticospinal. And there's a lateral corticospinal, and there's an anterior corticospinal. These are also known as the pyramidal tracts. The spinothalamic, spine, starting the spine, ending up in the thalamus, up in the brain, the thalamus. The lateral spinothalamic is dealing with the sensations of pain and temperature. And then the anterior spinothalamic, right? If we go back and we look, we have the anterior spinothalamic, which is here. And then we have a lateral spinothalamic. So these tracts are carrying different types of information. This is dealing with pain and temperature. This is dealing with crude touch. Okay? Deep pressure and crude touch from the anterior. The posterior columns, we know it's dealing with proprioceptive awareness, vibration, these two I mentioned earlier. But it also deals with discriminative touch. What we mean by this is you can take your fingers and you can be behind someone, take your right hand, your right pointer finger, touch their right shoulder, your left pointer finger, touch their left shoulder at the exact same time. And you could say to the person, how many fingers am I touching you with? They should be able to say 2. They can discriminate between their right shoulder and left. Then you could bring your fingers closer in. So maybe they're touching not the shoulders, but maybe the right pointer is touching the right scapula and the left pointer is touching the left scapula. You could ask them, how many fingers am I touching you with? Okay. They'll say 2. Great. They can discriminate the 2 points. Then if you bring it closer together, like one on the right transverse process of the spine and the left pointer on the left transverse process of the spine, and you go, how many places am I touching you? They'll probably say 1. And you could do this little experiment on a family member today and see how good they are at 2-point discrimination. Discriminative touches, where do you feel yourself being touched? Oh, you're right. I feel my right shoulder. Okay. What about this one? I feel it on my left scapula. Cool. So they can tell individually where they are being touched. Now, when you do 2-point discrimination, it's touching them with two different spots at the same time to see if they can differentiate. Pressure is, like walking. When your heel hits the ground, there's pressure and distortion at the calcaneus. Okay. The corticospinal tracts, which are known as the pyramidal tracts, they're also known as direct pathways. These are controlling precise voluntary movement. And the corticospinal tracts that you may have on the left side of the spine, okay, the corticospinal tracts that may start here will come down and crisscross to this side, and the corticospinal tracts here come down, crisscross, and go down this way. So those corticospinal tracts crisscross right at the level of the medulla in the neck. And this is why when someone has a stroke on one side of the brain, let's say on the left side of their brain, they become paralyzed on the opposite side of the body because of the wiring of those corticospinal tracts. Then we have these indirect pathways like rubrospinal and vestibulospinal. The vestibulo should sound a little bit familiar when you look at the ear, inside the ear. There are vestibular canals that control your balance and equilibrium. So these rubrospinal and vestibulospinal tracts are dealing with controlling autonomic, or I should say automatic movements. Like if you slip on something and your arms fling out in different directions and your head tilts one way to restore balance, like that righting reflex, it's automatic. You don't have to think about it. Your postural muscles, all your muscle tone, coordinating your equilibrium, your balance with your eyes and the visual reflexes. These are all somewhat subconscious. You don't really have to think about those type of pathways working. Thank goodness. Okay, we'll take a break here. When we come back, we'll get into the reflexes.